sick today? I don't see anyone.
Oh, maybe I gotta.
Oh, don't. Tea is terrible.
I haven't heard them. I haven't heard.
So you're gonna, since I won't be here today, but I want to just push it. So I'll just because I thought that last time.
It almost sounds like Google Meet. Right?
Yeah.
Get a better microphone, like maybe one that goes to a shirt. I think everyone agrees. Yeah. Not that. Not to go over home very close to home. Huh? Not to go over home. Get tired. Second grade in this class, so I already signed up for tutoring. Wait, how'd you sign up? Online. It's like Stop. Oh yeah, I used that last year. I didn't understand some of the problems with Word last night. And every time I asked my dad to explain, he explained it in some weird way. Stop. So, and now I'm even more confused than I was started. So I signed up for tutoring. I've never signed up for tutoring in my life where I wasn't for tutoring. So this is weird for me. This one will be on YouTube. I'll probably sign up with you. Can you tutor session? Because I was at the main campus yesterday in Main Street and I walked in and the library is on the second floor and there's a tutor in the center. So if I had time, probably sign up with them.
I've been consistently getting which means I could start sleeping 10 minutes later and still be here on time.
You're
Consistently been getting here like 10 minutes early.
Yeah.
Which means I can sleep a little bit more.
I feel that.
Or, make another pot of coffee and just bring the whole thing.
Bring the whole pot. I've also
Bring your bed
consistently
to the
been
room.
staying up till like 2:30 every night.
Bring a blanket.
My voice is going because of my lack of sleep.
I went to sleep at like 8:30 last night.
What? I haven't gone to bed at 8:30 since it was my bedtime in elementary school.
I got lots of question marks, that's all I can say.
I wish my
Same
parents
lots
would
are wrong
sing
answers,
for me.
but you know
But it's okay.
literally.
That's not mine. I didn't do this.
I tell you, if you look at these practices, the one at Facebook, we did all that on Facebook, they have.
She my racks down. That's what they are.
Yeah.
But Joy passed all of our cases.
I
I think there were proof of that.
Yeah.
We got a wire.
And I think I'm pretty familiar. I mean, we learned that in
See all the rest. Well, that's just.
I think it was the last one. Yeah, the last three.
Like 70s.
Just fill it out. Yeah, my neighbor who's in like Calc 4 already took Calc 4, she couldn't figure it out. She could figure out some of the others in that section.
So what do you do? What never?
Oh,
Instead of the equation,
Start.
and then you solve it for
I
x.
think I have to.
And then in the book,
But I tell you, business.
wait, no, never mind. I did figure it out eventually. When did I do that?
Oh my god.
You understood this? You answered right.
Well,
I think it's amazing.
33 or whatever.
29.
33 through
I think it's class.
38 or something. 30 to 38.
Oh, yeah.
For these,
Allowed to drive.
I didn't check that these were the same questions. I don't think they are because this is where we zero.
Yeah, I
So,
tried that.
it's not that
That was
much.
only our question. Yeah, 33.
Yeah, so what you would do for like H of G is,
When God comes to,
it's
yeah,
just
that might, route it at 100.
it's not
Yeah,
here
I
in the.
understand that. That would make sense to me, but do that doesn't.
That makes sense.
I mean, it's on the back, right?
So when you make your next row of that chart, you start at 0. So for your next function, for 0,
But if you plug in H
G of 0,
you get
which will be 1,
up to-
plugged in H, which will be 2. So
And then go on to what the next be in that order.
G of 1 will be 0, and then H of 0 is
You just use the chart.
you literally just move around the chart.
The easiest question of the whole thing.
Neither.
What did you say? I was gonna say something. I don't get how to do that.
You just plug it wherever. Like,
Yeah.
Not this name. Yeah, but here I had to connect one of them because it was causing my life. That one over there still makes a lot of noise. Yeah. First, yeah.
Handle it's loud. I know it.
I know.
I take some nerves on it.
Say what you were saying.
I'd be hesitant to see you gonna take nerds on something in the class. I'm pretty
Yeah,
sure,
I think that might be just a little bit too.
I'm pretty sure the room is full of them. Okay.
You go to where the top part is.
I don't know how.
And you go down to H.
This is a.
Towards that end is why I guess they are.
Yeah.
So. My neighbor like.
The bookstore isn't selling the book
either.
Yes, what do I need to do to get it? I have to go online, right?
Yeah, so
Since it's the same problem.
like.
I'm talking to,
Is one. So then one.
Allison.
Okay, we give you the warnings like I did yesterday.
That's fine, that's fine. Otherwise, I just have to pull my phone out.
Yeah, and there's not a
There's not a
clock.
clock.
Yeah, so.
That's what I was thinking.
They had something, I was like, no, I figured you would have it.
All the other things have a clock in the back.
You
They
take-
don't have it. So stuck on.
Yeah.
But it was like the same thing with my accounting class, too, they weren't selling that, and then this
But,
year.
you know, if the camera had like, red light, okay, almost going on air, you know.
Or you could do like they do at the end, you can start playing your get off the stage music.
You know if they have the text message?
I haven't heard anything.
I was gonna say my wife.
I'm working on it. Hopefully these punch will be okay for now.
See
You
me.
can figure out this hole punch up here, but I can't figure out the hole punch. If you want to come try, you are welcome to come try.
I guess it's about that time. So let me just get over here.
What's going on with this thing?
So I see, is Elise not here then? Dave's can you hear us?
Yes.
Is Elise there? I don't see her.
Not yet. There's someone walking in the hallway though.
Okay.
No, she's not here yet.
Oh, Dylan.
We're missing Elise and Dylan.
Pulled in when I was walking out of the car, so.
That's all. And Reza.
But he still had to go sign in. It's okay, I got it.
Yeah.
I don't know if I'm signing in.
No.
That means you're getting
counted
counted
absent
absent.
for.
Okay.
2 targets down at a time.
As long as you're college instructor, you're instructor down through there. I'll just sign in after class.
Or yeah, it's supposed to get it. You get it.
Yeah, sure, I'll go to that.
And you go to 1 and you go 2.
Yeah, that's.
I'm so scared.
Why are you
So
being
then you
such a
go
jerk
to
lately?
X
I'm not being a jerk.
1 to X.
You just think I'm being a jerk. You guys are being a jerk to me.
Okay, so how did it go last night, everyone?
I just got 3.5 hours.
How did it go? You thought you got caught up on section 1 now? Start on section 2? I wanted to congratulate several of you for noticing that there was a post on the forum. Several of you responded. That's fantastic. I want to take a minute to even talk about that a little bit. And didn't see it. There was an opportunity to earn some extra credit by participating in this forum. Here was the post and some responses. The post is about a particular problem. Saying, please describe how to draw a graph to meet the criteria. I think I might need an asymptote. I'm not sure. So I put some notes to be specific and precise in describing how to do this. I think there were a couple that got pretty close, but there was still some, I think, some more discussion we could have. Most everyone had a good example of what it needed to look like in their minds. But I think there's even further that we could go. Most had a graph, something like this, satisfied the criteria. The criteria was that the domain was 0 to infinity, that f of x was always negative, and f of x was always increasing. Those are the criteria you had to satisfy, and this does it. That's good. And we had a vertical asymptote at x equals 0, and a horizontal asymptote at y equals 0. Both of those required as shown. I mentioned that a vertical asymptote isn't required, but didn't really follow through much further, but that was good, because it's not required. But there was something else that was missed by, I think, everyone. Sammy did a good job of describing why it had to be in the 4th quadrant. It's because of these two conditions right here. Main condition tells me that we have to be in quadrants 1 or 4. That direction. The 1 and 4, and then this restriction here tells me I have to be in quadrants 3 or 4. That's okay. 4. So the only one that overlaps between those two conditions is this one right here. So it had to be in quadrant 4. Some stated quadrant 3. Others, several people said that simply this condition right there made it quadrant 4, but that's not true. This condition alone only gives you to the right half. And Sammy did discuss that. So those two had good, I think, starting discussions. Maybe if they had some more time to put their heads together, could have come up. But I also made another comment. Joe said you don't have to have a vertical asymptote, and I agree. We need to discuss that. And I would contend that the horizontal asymptote that is required does not have to be at 0. You all visualize a graph that would satisfy that thing. Y'all follow all that? Questions on what I just said? No idea what I just said. Okay. How many, let's use the thumb method. Yeah, I got what you said, and I'm just thinking, I'm sort of maybe almost, and I have no idea what you're talking about. Okay, everyone has to vote. Everyone put your hands up, this up.
So they may not see you. I'm
Oh,
sorry.
you can't see. Oh, you can't see. Oh, back there, you can't see me. Thumbs up means I really got this. This is good. I'm just thinking. This means, you might need to talk about a little bit more. This means, what, are we in math class? So, everyone votes. What do you think? I got a thumb up here. I got one thumbs up. I got a bunch of thumbs sideways. Okay, we need to talk a little bit more. Okay? One more time. These are the criteria that you were given, and you had to come up with a graph that satisfied it. Everyone, I believe everyone came up with this graph. And that does satisfy it, and that's good. The question I posed was, in addition to that, describe it and why. And so I was going through and explaining that the reason it's in quadrant 4 is, first of all, not solely, that criteria there does not restrict you only to quadrant 4. It restricts you to the right half, which is 1 and 4. It takes the second criteria, which restricts you to 3 and 4, to then narrow down to only quadrant 4. That was one comment. Next comment was, Joe mentioned in his reply that you don't have to have a vertical asymptote here. I agree. And the second comment I made was that I think there does have to be a horizontal asymptote, but I would contend the horizontal asymptote does not have to be at 0. That I can have a different horizontal asymptote and not even have a vertical asymptote and still satisfy this criteria. So this is correct. I mean, if you drew that, good. You got an A+. Well, you got an A-. Now let's get an A+ by looking at all the possibilities. So can you come up with a graph that A doesn't have a vertical asymptote and B doesn't have a horizontal at 0? Okay, the suggestion is let's put a horizontal asymptote at y equals -1. Okay, good. So now I'm going to get close to that horizontal asymptote. Is that keeping me satisfying the condition that f of x is less than 0? Sure. Now I still got to stay to the right half. How can I do that without a vertical asymptote?
How do we do that? You just stop it there, right? Okay.
All right, can y'all see what I just did there? I don't know if they can zoom in just a little more.
Please don't.
What did I do? I hit the axis, but I didn't put a solid dot there. I put an open circle. So what does that mean? You're coming up close to it, but you're not actually including it. But I'm not making an asymptote either. So this type of picture would also satisfy. And these are two different types of functions, by the way. This will lead in. This is like a plane. You know how you love it when a plan comes together? These two pictures actually can be tied to the next section in terms of transformations. This is a transformation of f of x equals 1 over x, called the hyperbola. Have you heard of the hyperbola before? Have you seen that graph?
Yeah.
Anybody recognize what this might be related to? What if I extended this graph, which isn't part of it, but what if because I'm restricted, but what if I extended this graph like that? Pardon me? Well, this is a transformation of f of x equals equals E. Exponential function. Okay? That comes up in the very next section. Okay, so I'll give some extra credit for everyone who replied. I'll give an extra point to Joe and Sammy for your responses. Y'all got real close and still left out. So good job for everyone to respond. I appreciate your participation. I hope that it will continue for the rest of the semester as we go forward. And I will occasionally, probably just to make sure I'm paying attention, pop an extra credit type of question like that and just to help keep participation up and everybody wanting to post on that discussion. I think it's a good way for us to communicate across distances. Okay, well, that was all I wanted to show you from that. So next up, what questions do you have homework? Oh, one more thing, I was going to show you this real quick. Can you put it back? So here's the graphs I was talking about. I'll show you the transformations. I don't know if y'all can see. Y'all see that on there? At least you see. Okay. So this upper curve is the transformation of 1 over x. This curve is a transformation of e to the x, and I can show you those. First one I have is negative 1 over x. That one's negative 1 over x, and it's going from x greater than 0. And then the second one is negative e raised to the negative e raised to the negative x minus 5. So that's shifted down 5. And also, I have a domain constriction of x greater than 0 on that one as well. So that's how I got that graph. Y'all familiar with technology and making restricted domains like that? Has anybody ever done restricted domains on your calculator before? You know what I mean by restricted domains on your calculator?
Yes.
I understand the question, but you've never done it. So restricted domain means not all real numbers. So I made the domain be from x greater than 0. That's how I graph. You only graph part of the little picture again. It only graphs the right half of those functions.
Restricted domain on a calculator only goes like that.
Yes. So if you want to restrict the domain, you have to put the function in parentheses. You have to put the domain in parentheses. The domain, to get your inequality symbols, you can just go to test. Test. Okay. I think I'm done with that. Unless there's questions on that. So now on homework, on which step are we in a second? Why do I need to? Assuming section 2, number 1. Are you on section 1 or section 2? Section 1. Okay, we'll do section 1 number 3. Are there any others in section 1 that you want to discuss? Way out there. We're trying to wrap up on section 1 today. Anybody else? I just want to write down the numbers so I know how many I got to deal with. Section 1. Well, I have one question. That's fantastic. For each situation described, identify independent and dependent variables and express their relationship as an equation. Multivariable function notation. See example 9. Example 9. Let's go back and see what example 9 is. Example 9. So we have a function mapping from one dimension like R into R cubed, which means 3 dimensions. For maybe from R squared into R squared, which is 2 dimensions onto 2 dimensions. Okay, so let's see what we've got. H is the length of the hypotenuse of the right triangle. The legs, length A and B.
Which question is this?
That's right. This is number 83 on page 17.
Thank you.
Anybody have a suggested equation? First of all, do you know what the mapping domain and codomain looks like? Is it like R onto R cubed or R onto R? You know, like they do, right? They have like a function maps from real numbers into real numbers, or what? This would be your domain, and this is your codomain over here. Sorry. That's fine. I'll do it.
It's very responsive today.
Very slow today?
No, it's very quick today.
Oh, it's quick today. Well, that's good. That's good. Or you could do, well, maybe it's R onto R squared. Or it could be R squared onto R. You got lots of possibilities. Normally, in pre-calculus, you only deal with the very first case. You have one input variable and one output variable. That's not the only case in the world. You can have multiple variable input. You can have multiple variable output. You can have multiple variable input and one variable output. This would be one variable input and 2 variable output. Are we with me on all this? So these are the types of possibilities. You know, examples of this might be something like f of x equals 7x. And this example might be something like f of x equals x minus 3 and x squared. This example might be f of x comma y equals x squared minus 7y divided by x times x times y minus something like that, whatever. So I'm generating from 2 variables. I'm generating one response. Here, from one input, I'm generating 2 responses. So what do we need for this one? That's just the kind of background. We need this problem. Hypotenuse of a right triangle with leg, length, angle. We all know that, right? What's the point?
A squared plus B squared equals C squared.
I'm sorry, I can't speak up.
A squared plus B squared equals C squared? Is that what you're
Yes,
looking?
that's the Pythagorean theorem. Those crazy Pythagoreans, they're the ones that gave us irrational numbers, right? Y'all know that?
Mm-hmm.
Before Pythagoras, we only had fractions. And then Pythagoras and his Pythagorean followers proved through the Pythagorean theorem that you can have irrational numbers. That's how it got its name, because irrational means not making any sense. And at the time, fractions were the only thing that made sense. So it was heresy to talk about something that wasn't a fraction. Okay, so you said for this particular example, I heard something like, what did you say? A squared plus B squared equals C squared. That's called Pythagorean theorem. What are we trying to figure out from this problem? What's it say?
trying to express the relationship as an equation with the variables that were given.
Okay? And what are we looking for as an output from our equation? Right? Which one do we want? Okay, so let's go back to independent dependent. Let's make sure we're clear on that. You're right. Okay. So in this setup, my x is my independent variable, and my f of x is my dependent variable. So that's like the y value. The y is dependent. This is dependent. And this x is independent. Same thing here. You have x, independent variable x and dependent variable y. Here, however, we have two independent variables, and this might be equal to c. That's your
Our independent.
Again, I'm sorry.
The independent variables for this would be a and b.
Yes.
Because you're going to put that in to get your output of h, which is the hyperparameter.
Correct. So we have this time two independent variables and one dependent variable. So that means we must look something like this. So that means we're mapping from r squared into r. And what would the formula look like? H of a comma b equals what?
The square root of a squared plus b squared.
That wasn't so bad. But it's good to know the theory behind what's going on, so that if you had to do it on another type of problem, it would make more sense. This, that's fairly straightforward because it's Pythagorean theorem. We've done that since 7th grade. Okay. What's the other one? Oh, by the way, what are the independent? Are you cool with that one? Hang on a second. That was Emily, right?
Yes, sir.
Provided for us the independent dependent variables. Is that Emily?
Yeah.
You told us that the independent variables for A and B and F, B. Okay, good. What about part B? Again, louder. Yes. Yes. So I hear that the dimensions x, y, and z would be your independent variables, and the volume v would be your dependent variable. And so you would write what equation?
Could you zoom out a little? We can't see the board.
Oh, yeah. I got a little low for you.
Better?
No.
A little more.
We haven't seen it again.
Well, it's okay, actually.
That's good. So the first one, what type of mapping is that again? We talked about it in terms of mapping. So let's call it this. Carson, what do you think? Which type of mapping is this first one that we're doing? Can you give me something like this for the mapping?
You said me.
They said you, buddy.
Pick one of these. We'll make up another one that would be similar, that would satisfy or relate to this equation. What do you help first now? Basically, you tell me.
So for h of ab,
That's
that
what
would
you
be
already told us.
r squared to r? Is that what you're referring
Yes.
to?
Yes, so this is h mapping r squared to r. That's correct.
Okay, we'll keep on going with it.
What about the second one? The second one is B is mapping R Q to R.
I get it.
So one more call or question. Did everyone follow this thinking here on this? What other questions in section 1 do you feel you're still concerned about before we start on section 2? Think about it. Number 70, I heard. Okay. Number 70, the restrictions are concave down, then concave up, and then always increase. So concave down on negative infinity 2. Is that correct? What I have there?
Right.
Concave up on 2 to infinity. And
I get it.
okay, so all I did there was take some time to write the problem. We already in the book. Take some time for the camera to catch up. We're good to go. So we're good to go.
Yeah. One day it's slow, one day it's fast.
Exactly. It's like, okay, so how do we accommodate? I guess to me somehow something at 2 is changing.
Yeah.
This is always increasing. Then my graph, as I read from left to right, has to be going up all the time. So it looks like it's probably going to have to be pointing down here somehow and pointing up there somehow. And then it has to connect through there going up somehow. How? What does it mean to be concave down? Yeah, it's got to have the palm of your hand has to be down if it's concave down. If it's concave up, the palm of your hand has to be up. So concave down until you get to 2. And after you get to 2, that'll be concave. Does this point here, what's that point called that I just created? This little special point right there, which is supposed to be
Inflection point.
It's called what?
The inflection point.
Inflection point, that's right. Does that inflection point have to be where I showed it? Or could the inflection point be on the axis? Or could it be up here somewhere? What's the only restriction on the inflection point? It has to be at x equals 2. The y height of it does not matter. This satisfies all of this criteria, but then there could be another graph just like it that would satisfy the criteria. That one also satisfies the criteria. So there's not just one answer, there's more. Good. That's all.
Got him.
What about section 2 then? What's section 2 about?
Functions.
And Please, say something. Is that Rizzo?
Functions. I mean, chapter 1 was about functions, but this was also about it too, I guess.
Transformations and stuff.
Yeah, that too.
Transformations, yes, have transformations in it. Good. Even odd, was that in there?
Yes.
Okay. Good. Inverse functions. Let's look at problem 1, like we did yesterday. Can I volunteer to take 1A? Volunteers. Go figure. It's no problem. Joe, you wanted? Did you say you wanted? Can you read it for us, please? Loud enough for everyone to hear.
Domain of a function of the form f plus g is equal to the domain f or the domain of g, whichever is smallest.
Said you think it's false. Okay. You don't know why. Okay, good. There's a definition. I agree it's false. What's the definition say about the domain of that? Page 19. What does it say? Y'all have help out here? About Britain. What do you think? What does it say that the domain has to be for a function f plus 2?
It has to be both the F and G domains.
It's both. So it's careful. It's all the x values that are in both of them at the same time. So it's really the intersection between the two domains. So the domain of f plus g is the domain. So the domain of f plus g is equal to the domain of f intersecting with the domain of g. So the set that's called the domain for this function is not the smallest of the two. That's not what it says. It is only the x values that are in both of them at the same time. Now, when would it be? Now, it's possible. It's possible that it would be, in fact, the smallest of, quote, the smallest of the two. When would it be that it would? There are cases, but that's not a universal statement. There are cases where the smallest of the two would satisfy this statement here. This is the correct statement, universal. Occasionally, the smallest of the two will also be a domain. When is that going to happen? Yes. If one of the domains is a subset of the other domain, you know what subset means?
Yes.
Yes, what does it mean? Explain to us. Subset.
Is it like a small part of a larger set?
Correct. So it's a set contained within the other set. So if for example, set F domain was contained within set G domain, so all the numbers in F you can find in G, then the intersection between the two will be just the smaller of the two. Y'all know what intersection means? I'm assuming you know these terminologies. What's the intersection of two sets? Can you describe that for us? Yeah, where the two sets cross over. Okay, good. What about 1G? A new volunteer. Bree, you want to take that one, please?
Sure. True or false? The domain of a function of the form f of g is equal to the intersection of the domains of f and g. Okay.
Read that again.
Okay. The domain of a function of the form f of g is equal to the intersection of the domain
Pause
of
right there. That's not f of g.
Oh, sorry.
The symbol there is not, I don't think it's f times g.
Oh. Okay. Well, then my answer is going to be.
Let's review for everyone's sake. Okay, so you've got f plus g of x equals f of x plus g of x. F times g, x equals f of x times g of x. F divided by g of x is equal to f of x divided by g of x. And f circle g of x. That's not a time sign. That's called a circle. And just like these have a name, plus, time, divide, this has a name called circle. It's a binary operator just like these. It has to have two things, one on either side, and it does something with it. And what it does is f of g of x. Sweet. This is f of g of x, this is f circle g, this is f times g. Okay, so one more time. Start over, please.
Okay.
Let's go through it.
The domain of a function of the form f times g is equal to the intersection of the domains of f and g.
That is?
True. True.
Didn't hear you.
True.
True. I agree, it is true. In fact, that's what it says on page, whatever word that we just worked. Page 19. For the product, domain is in both f and g simultaneously, so that's still the same. So I could change from plus to times and still be true. Okay, what about C? Volunteer.
What do you think you're doing?
Okay, do you want me to go?
Volunteer.
Oh, okay.
Hey, did you wave and say I'm volunteering?
Yes.
Fantastic. Give this man a promotion. He's no longer a buck private. We're going to make him a corporal. Good.
Corporal.
Okay, so true or false? If the graph of y equals f of x contains the point AB, then the graph of y equals f of x plus c must contain the point A, comma, b plus c. And I said this is true because c moves the whole function up by c. It's just basic properties of changing the y-intercept.
Correct. Exactly. You're transforming your the scale on your axes. It's like doing effectively it's like doing a changing your window on your graphing calculator. If you put a multiplier in a function, it's like changing the zoom setting. If you put an addition of a number, it's like simply moving the window to a different place. And imagining that the axis system is no longer what's drawn by your TI calculator, but is at the center of your viewing window. If you imagine it that way, think of that's actually important. You're absolutely right, and I agree with you. I'm now thinking ahead. My brain is on 4 chapters from now. Transformations are usually discussed as moving the graph, but it's oftentimes better to think of it as moving the coordinate system, changing the coordinate system, transforming the coordinate system to a different scale. That's a little bit hard to think of, but start trying to think that way. We'll talk more about that later. Yes, that's right. Good. How about D? Volunteer? All right. We have Dylan volunteering. Fantastic. We got another corporal amongst us.
True or false, if the graph of y equals f of x contains the point A and B, then the graph of y of f of x plus c must contain the point A plus c, B.
You said I couldn't hear you.
Oh, I was just repeating the question.
Oh, yes, I heard that. Did you answer whether it was true or false?
Oh, no, I didn't. I put it as false.
Okay, good. I agree. Why is that?
Because when you add a number to the x, it moves it to the left. And in this case, it's moving it to the right, the coordinate.
That's good.
I agree. Again, why is that? Because now it's absolutely right. That's the left and the right business. You have that exactly right. Why does it? The opposite of what you might think. Why does f of x plus c move it to the left and not to the right?
Wow. I used to know.
F of x plus c does one thing, and f of x plus c, this goes as expected. This goes the opposite of expected.
Yeah.
Y'all know that this goes.
I can't see.
Can't see, sorry.
There we go. That's good.
I'm a literate.
So we all know that this one goes in the direction of C, up and down.
Mm-hmm.
This one goes this way, but it goes with negative of C. It goes the opposite direction. But why? Why would you just randomly decide to make it the opposite direction when it's in there, and the correct what you would expect when it's on Y? This one's changing. You're modifying Y here. This is a Y value, and this is an X value. So when you modify the Y value, it does what you would expect. When you modify the X, it does the opposite. And I find that if I just kind of memorize something like that, I get confused. So I try to understand. So if you say that g of x equals f of x plus 4, then everyone's going to tell me what? The g of x moves which way as compared to f? Got to go to the left. That's right. I agree. Well, let's visualize and graph. So let's suppose that this point right there is f of x. I want to find g of x so that the y values are the same. This is the y value, and that's a y value. I want it to be the same. I want g of x to be the f at x plus 4. So I really want that to become f of x plus 4 in some fashion. So I want to find some place on the graph so that if I add 4 to it, I can then calculate my f value and get this same height. Well, if I'm going to find a location so that I add 4 and get to there, then I've got to start over here, 4 units back, because then when I add 4, I can get to the right spot. To me, that visualization helps me. But yes, you're right. This is going to move it left. Absolutely. That's the graph. Okay, let's keep going. I get sidetracked usually get on the tangents. Okay, E. Answer for E. Al, you look like you want to volunteer. Al?
Who, me? No.
Al. Can you hear me, Kyle?
Yeah, I can hear you.
The inverse of the one-to-one function of f of x equals, I think that's x cubed, is the inverse.
What?
We're doing e, right?
Yeah. Mine doesn't say x cubed.
Looks like, well, it looked like x cubed, but it's actually x to the fifth, I was just told. But that doesn't really change the answer. So.
Well, what is it that you're seeing there? Is it x cubed or is it something else?
Well, I have a scanned copy of the textbooks.
Oh, I got you a scanned copy. Well, I apologize. No wonder you can't read it. It says x cubed.
I'm not illiterate.
Yeah, I'm not illiterate. I just can't.
I'm like, are you? Okay. Now I get it. You got a scanned copy.
Well, I put false.
My eyes are bad, but I can see that's not a three. Okay. It's x to the fifth.
Yeah, roasted.
I put false, but I don't know.
It's false. Okay. But what should it be? What should the index be?
Wouldn't it be, well, you can't, just because you put negative, like a -5 doesn't mean that it's an inverse, I feel like, right?
Correct. So what would the inverse be?
We're on E.
I said that's deep.
Oh, that's deep. Would it be, I don't know.
You got him.
Well, to help out, let me give you a hint to help out. What does an inverse function do?
Reverse is what you just did.
I think I heard somebody say something. Say again.
It undoes the function.
Undoes the function. That's exactly right. So if f of x equals x to the fifth, so then say f of 2 equals 2 to the fifth, which is 32.
I'm sorry.
You're okay.
I swear I'm not drunk.
I mean, it's only like 8 in the morning. I imagine it's too early.
She could be.
That's the problem. It's 8 in the morning. We're not here. It needs to be about 10:30 or something.
Is that okay there? Can you see?
You all see that now?
Yeah, that's good.
Okay, good. So there's your f of x. So that means I want f inverse to take 32 and make a 2. So what does that mean that f inverse of x has 2? Clearly, it's not. Clearly, it is not x to the -5, which is 1 over x to the fifth, because that would give me a 1 over 32. That's not what I want. I don't want a 1 over 30 or no, that would be 1 over 32 to the fifth. 1 over 32 to the fifth. That's not a good answer. I want 2. I want a number 2. Not that. That's crazy. That can't.
Okay.
What does it got to be?
Quint root.
The fifth root.
The quint root.
Yes, thank you. The fifth root. Okay.
Adam.
All right. About yeah. Man, you want to take that?
That is it.
F to the -1, we read it as not f to the -1, but f inverse, right? Yes. So when we're talking exponents on a regular variable, like over here I was just talking, x to the -5 is read as x to the -5, and it means we interpret or define it to be a reciprocal. But when we put a negative exponent 1 on a function name, we don't read it as negative to the -1, we read it as inverse, and it definitely does not mean 1 over f. So that would only be a separate issue. So I agree with you. Good. G. How about Josh?
It reads true or false. Every even function is a function that involves only even exponents. And I got false due to the definition of an even function and how it's symmetric with the y-axis.
Okay. An even function is in fact symmetric to the y-axis. I agree with that. In fact, if you have a polynomial function and all of the exponents are even, it will be an even function. But are all functions polynomial functions?
No.
Oh, can you name a function for me that's even, that's not polynomial? That would help me to believe that you know that this is true and false.
Y equals 1.
Sorry?
Equals 1.
1? Say 1?
Yes, y equals 1.
So you're saying y equals 1?
It's a journey.
It's a journey. Well, I have to race and take my time here. So I heard y equals 1. I agree, y equals 1 is even.
See? It's symmetrical.
But the criteria was I wanted a function that was not polynomial. In fact, that is polynomial.
How?
Because this is 1 times x equals 0.
I don't believe
No, I'm sorry, that's polynomial. That was an excellent suggestion, but I'm sorry, you still lose. Okay, somebody else. You come up with a function that you know about that is even and not polynomial. I heard somebody say that thing.
Cosine.
Yes. I equals cosine of x. That's not polynomial.
His heart was hurting.
I know.
How is that not a polynomial?
Because it's trigonometric.
Okay. I'll take it. I'll just accept
Cosine of
it.
x is called a transcendental function. Transcendental means well, we'll get that later. Transcendental. Transcends.
Being the Himalayas, man.
Polynomial functions are a special subcase of what are known as algebraic functions.
That's cute. It is. Well, it's true.
Transcendental functions and algebraic functions are quite distinct. E to the x is also transcendental. It is not algebraic. We'll learn later that transcendental functions can be viewed as an infinite sum polynomial. That's not a polynomial once it's infinite, but a polynomial has to have a finite number of terms, like x squared plus 3x plus 5. That's a polynomial between 2 and 3 terms. But if we had infinite number of terms of a certain pattern, we can represent cosine of x as a sort of like polynomial. That's why it's called transcendental. It transcends the finite. It becomes infinite. We'll get back to that later. Okay. Where are we? Number H. Volunteer. How about Sydney? Sydney's hiding back in the dark corner. Let's see.
If h is an even function and 0b is a point on the graph of y equals f of x, then 0 negative b must be on the graph of y equals f of x. I said false.
You said false because why? It's if it's even. 0b is on the graph of that. 0 negative. Is that not even? is that false? I agree with you, it's false. Wow.
Similar for flag. Okay.
Those are the points that said should be on the graph. You see any problems with that?
Yeah, I do see a problem with that.
Oh,
Am I allowed to answer? Okay. An even function is supposed to be symmetrical about the y-axis, and that flips the x value.
Well, then not make it a function.
so this
Right,
is symmetric about the x-axis, not symmetric about the y-axis.
Yeah.
Correct. I agree. So even has to be symmetric on y. I agree with you. Absolutely. There's a problem. It's not symmetric on the y. Why else is it not? Why else is it not an even function? Because it's not even a function. It's not a function, folks. We're blind tests.
I don't see no function.
It's not a function. It cannot be an even.
Got him.
Okay. What other questions? I think we. So that was question number one. Now you have some more questions in here, exercises. Have you tried some of those? And if so, what kind of questions?
Could you go over question number 2?
Number 2. So I'll try. Correct examples of the things described in the following. Well, I define examples that are different than any in the reading. A pair of functions f and g, for which f circle g happens to be equal to g circle f. So we want f circle g of x to be equal to g of f. Well, this means we want f of g of x, g of f.
You can just make this a function. Got him. Just make them the same.
Do I think of a function that would work for f of g in that situation?
That's a dumb answer.
I don't know, I'm just going to make something up. I don't know anything else to try. Let's try something simple. Let's let f of x equal x plus 2. And let's let g of x equal x minus.
Can you move it to the right a little, please? Please? Thank you.
That's good.
I good now? Okay. Good. So, does that work now?
Yeah.
Yeah, I think.
I think so. I hope. I don't know. Maybe not. F of g of x is x minus 2. And f means x plus 2, so that's x minus 2 plus 2, which comes out to the x. This side says g of f is x plus 2. But then g says x minus 2, so x plus 2 minus 2.
Yeah,
which turns out to be X.
That's the
So
we get straight
Yep.
commuted this piece.
that one worked. That was a lucky first guess. There's the only one out there? Go. Watson. In fact,
Makes sense, right?
that's actually the definition. Since we're on this problem, it's an opportunity. Compare 2A, two functions where f circle g happens to be equal to g circle f. Let's go back to, for a moment, page 23. Look at the definition of an inverse of a function. Say.
Wait, what page is it?
Page 23. F and g are functions such that g of f of x is equal to x, and f of g of x is equal to x. Then g is said to be the inverse of f, and we write it as f inverse.
That's cute.
So knowing that definition, that having both compositions, both directions of composition, can come out to be x on both of them, then you have an inverse, gave me the insight to think, well, wait a minute, if I'm adding 2, then the opposite of that, or the undoing of it, is subtracting 2. So I knew going in that this undid that, and therefore they were going to come out to be x and have the same value. So I knew that. It wasn't just a random guess. It was based on knowing the definition of inverse. Okay, so what about B? A function f that is its own inverse.
That one got me stumped. I'm not really my ex.
Oh, gosh.
I wonder how long until we can make that joke again.
So we want f of x to be equal to f inverse. So whatever function we pick, the inverse of it, the opposite of it, the undoing of it, has to be the same. Now, some other information that would be helpful to you about inverse functions. Besides what we just discussed, there's another aspect of inverse functions that you should be aware of. On page, and this will help, I think, 24, bottom of the page, they talk about the graph of an inverse function. Are you familiar with, we're out of time. Oh, are you familiar with the graph? What's the graph of the inverse function look like?
What was the question?
What's the graph of an inverse function?
Symmetric across the line y equals x. So this has to be symmetric across line y equals x as compared to that function. So if you have function f doing this, and you got the line y equal x like that, then the symmetry of that is, so this is f and this is f inverse. They go across the line y equals x. Well, think about that and see if you can come up with a function that will satisfy that and be symmetric across the line y equals x, but be the same. How about f equals x?
I got that. Yes. Yes. I'm a winner.
What does that say?
Now, the symmetry of f of x equals x is the same as itself, so the inverse.
That is smart.
That's what I've been told. We're out of time, so we can stop. So, we'll see you tomorrow. Go ahead and finish up on section 2 and start working on section 3 for tomorrow as well.
Wait, so section 3 is for tomorrow?
Just before we dismiss, if you have not completed the mandatory course enrollment assignment in Moodle, there's still a couple of people that have not, and you need to do that right away.
Already got Yeah. I'm a lineman for the county.
Can they still hear us?
All right, so I need to remember to tell you this. First of all, Joe, the lady over there that's doing the camera, wanted to see if you guys could put a picture in Moodle of yourself.
Okay.
Also, answer the question in Moodle or you're going to get kicked out of the course.
Gosh.
Attendance.
Be a disaster.
You missed the whole conversation about attendance. You get 3 points per day, like he was talking about. No, you missed it yesterday. I will be in here until like 9:45 or 10 o'clock if you have extra questions that you want to go over. And Dale said, oh, one last thing. Let me put this down because I'm waving it at you.
Yeah, I got scared.
Peer tutoring, if you're interested in peer tutoring for 171.
What does that mean? Which one is that?
Pre-calc algebra. If you're interested in doing that, then talk to Allison Holmes. And she doesn't really know what she can give you yet, but you can talk to her and express interest in tutoring for 171. I think Math Club is going to meet Tuesday at 3 o'clock.
Oh, I forgot about Math.
I have class.
What about Thursdays at 3 o'clock?
I have Tuesday, Thursday class.
We can do Monday and Wednesday, but not Tuesday, Thursday.
So Wednesday at 3 o'clock?
Yeah. Yeah, I can do that. Monday. Sure.
What about Wednesday at 2:30?
No, we have biology.
Oh, Lucy won't care.
But today.
Yeah.
What time is your class over on Wednesday?
2:50.
Okay.
But they can get out early, right?
No. Is it Monday and Wednesday?
No, it's just Wednesday.
So what about Monday at 2:30?
Why would you?
Early, then she lets you out whenever.
That would make me
Look, bagels can't
Mondays, yeah, Mondays are bad.
Because then you could sign out because this is like on the college campus and it's not like
Go home.
Okay, so Wednesdays at 3 o'clock.
How about 2? How about we get them?
Wednesdays at 3 o'clock
That's perfect.
not until
That's
when.
good.
till whenever we get finished talking.
Do.
I mean, you don't have to stay the whole time. And Dale said, just speak up in class. Say, hey, I know the answer. You don't have to raise your hand. He said, because you may miss your yeah. So, but I mean, oh my God, it's so hard for me not to answer these questions.
But Miss Klinger, I just feel
Well,
like
you should answer.
you just.
You need to get a whiteboard up there, write the answer on it, and just hold it up so one of us can say it.
Yeah, it's like. There's
Is he gonna
random
teach us
put it all
eventually?
together and
Is he gonna start like doing lessons on the board? Or is it just reviewing a book?
I don't know, because right now you're in the review section,
Yeah.
so I'm not real sure.
Yeah.
I think it'll be different after you get out of the review.
Miss Klinger, I have questions.
Never felt
I'll have questions later, Miss
What do you
Klinger. I'm
want
too
to do?
tired right now.
You wanna go to the lab already? Or
What do I need to do about the book, Miss Klinger?
Why don't you go talk to Allison about it, and then I will
But she
reiterate.
intimidates me.
Why does she intimidate you?
Of all
No.
the people to be intimidated
She's
by,
not
that is not one of them.
If this class keeps going like this, I'm gonna have to drop it.
Yeah, same.
Because, like, I'm sorry. I'm not trying to be like a
Because you
sarcastic.
don't need it.
No, I do need it. That's the thing, but I don't need it from him because I'm not learning it. You know, like, if I.
People learn in different ways. Let me
And
just
this
tell
is
you
not-
about my calculus class in college.
Here's my dilemma. This is bad, but who's to say when I go to college I'm not going to have some man who barely speaks English
Let me tell you
trying
about
to
my
teach me?
calculus class in college. So the first one I was ever in was Calc 3. That's where I started. And
How did you start at Calc 3? Like, you.
because of AP Calc.
Oh, okay.
Duh.
Yeah, that makes sense. Yeah.
Oh.
Well, no,
Um,
but. That
I
makes
mean, you guys will start in Calc 3.
Too.
No,
You
probably.
Calc
took
2 is
Calc 2
next-
next semester.
Another calculus from this man.
Yeah, it's not
I
gonna be
only
from him,
need
will it?
This one.
Why can't you just teach it?
Because I don't have enough hours in the day. This is like my planning period.
But
not
you
already
would
got-
love
to
to
plan when your kids are failing.
Yeah.
So my calculus teacher in high school was in college was legally blind, memorized the whole textbook, would come in with a piece of chalk and say, tell me how to do number 10. Turn to page 516. and he memorized the whole textbook.
Page 516.
But how did he grade
Yeah.
your tech like stuff?
He had a work study, which was me, the end of my schooling. But I mean, he was legally blind, so his glasses were like this thick.
Okay, but see, my thing is like I don't know what to do because reading the textbook and then trying to do problems does not work for me because I need it like shown out in front
At
of me.
least you read it.
But here's another thing.
Yeah, but
Like,
reading it doesn't help me. Like,
if I don't take it now and I take it when I go to like a four-year university, even if it is this bad or whatever, there's like student.
And if you end up
peers
going to
and
Chapel
stuff.
Hill, you'll have like 100 people in your class.
I know Chapel Hill's not my first choice, but
yeah, app's mine, so I don't think that there's
there's
gonna be
like
100 people in my class.
mine's Clemson, so I doubt it'd be any better. But Clemson guarantees that there are 0 classes.
But
taught
you
by
know what
student
though?
Teachers.
Hold on. My sister went to Clemson.
Carolina, you'll get a grad
and
assistant teaching calculus.
She said that their math teachers are phenomenal. 'Cause she was a chemistry major, so she had to have.
I was a graduate teaching assistant, and I was pretty phenomenal.
I'm just saying, I think I'm gonna have to drop this class if it continues this way, because I just feel like, and I mean, I'm sure he's a great guy and a great teacher, but like, I just feel like.
I think you guys have learned a lot that you forgot.
Can we find out what questions we gotta do for the homework?
It's on the Moodle page.
No, we don't.
I have them written down somewhere.
See, at this point, I would rather just like
So you're with me, Bree. You
drive
understand
your
where I'm
car
coming
into
from.
a tree.
I know. I was thinking about like, what if I just don't show up to class anymore? Like, I shouldn't have done the Moodle assignment. I should have just.
I know.
let it
I
have
was
me.
the other day. I was like, I should have just been a no-show.
Yeah.
There is a drop date.
Well, see, the thing is, I don't want to drop it, but I want to get it done. But
I don't know what to do.
is it D? Like, a D's not going to transfer over, so I'm going to have to take it anyway. You know,
If I
like.
go to Clemson, I'm gonna have to take it anyway, so it's not like they're gonna take it.
So, Clemson's fun. Clemson's
Just explain how hard the class was and they'll take it.
I will go talk to the admissions counselor and be like, let me just tell you something.
All right, 0.3, the homework is number 1, 13 through 17 odd.
Of course, number 1, I was freaking true or false. Explain why. I don't know why.
25 through
I don't even know if it's
53,
true or false.
every other odd.
I hit my line.
Oh my god.
And then 73 through 79 odd.
Is that it?
So am I the only student that doesn't have a book?
No, there's 4 of you. 5 of you.
Yeah, the Charlotte. I thought it was a 3-2. I was like,